Hey everybody, we're still on, I guess, sort of an introduction to exponential functions, but in this video we're going to analyze simple blocks of text about exponential um, functions. And to begin with here, we're just going to read this and sort of take it apart and label things as they are and try to answer this question, okay? All right, so when we hear about annual interest rates and things like that, that is what these formulas apply to that we talked about earlier. That's where do we have them? That's these guys right here. So oftentimes, actually, this principle is usually like a deposit, initial amount of money in an account. This is your rate and this is your time. So when you read a block of this text, it's fairly easy just to spot those elements within it. So this simple form right here, they're not too bad to answer. Then when they say $6,900 is placed in an account, that is your principal, right? And then they say with an annual interest rate of 8.25%, well, there's your R. It's given to you explicitly how much will be in the account in 26 years. So how much is your, I guess, your A of t, right? If it said how long will it take to get a certain amount, that's a much harder question to answer, and that's what we'll need the logarithmic function to do. So let's get started and answer this one, and we'll just kind of go through these. This won't take too long because they're not too awfully bad. All right, it says $6,900 is in deposited. I'm going to say A of t. We're putting in 6,900. All right, we want 1. Now we know it's growth. How much will be in the account? I don't assume that it's taking money out of the account. Now the rate. If you look here, it's 8.25%. You got to move that decimal over, so we'll call it 0.0825. How much time do we need? And it looks like for 26 years. So we're going to put in to the 26th power. And there's one little mistake I made here. This should be A of 26, really. Right, there should be a 26 for t. All right, so let's hand the amount after 26 years. And look, when you do calculate this, just plug it into your TI-84. Desmos would do just fine too. And we're going to raise 1 plus 0.0825 to the 26th power, and we're going to get $54,196.92. All right, so that's our answer. We got $54,196. It says round to the nearest cent. That would be 92 cents. Okay. So that's how you would handle this one. And there's one more I want to do with you, and we'll call it good on these. There's a couple of these problems I want you to do. And these are Math 1 level. Okay, so I know this is pretty easy. I'm not trying to insult your intelligence with these, but it's a good warm-up to looking at these things, right? Because in this course, we're going to be asked more difficult questions than this, and they will want exact answers. So it says an element with a mass of 310 grams decays by 8.9% per minute. How much of the element is remaining after 19 minutes to the nearest tenth of a gram? All right, so the word decay indicates that this is going to need an exponential decay formula problem, and we can set it up the same way. And we're looking at 19 minutes, and it's changing per minute, so they're not trying to mess me up with units. Be careful and look for that in these problems. Sometimes they do that to you. All right, so we're going to look at, this time I'll do it the right way. A of 19, right, equals, well, there's 310 grams of it initially. We need, the rate is this time 8.9%, so I'm going to move my decimal over and call it 0.89, and I need to raise that to the 19th power. And let's see what we get. We'll clear this guy out, and we'll put this one in. 310 raised to 1 minus 0.089. Raise that thing to the 19th. And we get 52.7 grams. So they wanted to the nearest tenth of a gram. So we would say 52, approximately 52.7 grams. All right, that's how you do a few of these, and hopefully that's helpful for you. And we'll get into the natural exponential function in the next video, and I'll see you there.